uh, and, and then start the session. So kindly wait for few minutes. Okay, I think we shall start the session now. Good afternoon, and I welcome you to this session. This is B.K. Mishra from Capricorn Technologies. I am the business manager, and this session we are going to cover on the the complete life cycle of the EPC solar EPC projects, how it can be covered using Autodesk solution. So along with my colleague Upendra and Shweta, we'll be running through this session. And please drop your queries in the chat box. At the end of the session, we will have an open house. We will unmute all of you and you can ask the queries. We will go a little slow in the benefit of the customers because the guests here, they come from variety of industries and segments. So we will go a bit slow, and we hope the session is beneficial to you. So with that, we will start the session now. So a couple of words for Capricorn Technologies. We are 30 years into this business across India, 15,000 customers. And now, of course, we are part of a global group called Win Zero, which will work towards business sustainability, reducing the carbon footprinting through our engineering, technology, and support processes. we cover multiple segments including architectural segment, which is major of our business, manufacturing, education, media and entertainment, government, and also the consulting services. Now, coming to the session, the digital transformation. Now, as we look at the solar industry, it is growing heap and bounds. Rather, in last couple of years, we have seen some major changes technologically, project size, the cost, and other factors changing dramatically in this segment. So much so that today we are almost more than 60 GW of solar projects, and now we are very quickly heading towards 100 capacity. So this could mean that lot many new projects, including major more than 2 gigawatts, could be in the planning, and probably lot of them are already under progress today. And I mean, talking about the bigger projects, the bigger one is 2.25 gigawatt with 14,000 acres of land. So that itself would bring us the enormous size of complexities in terms of designing, BOQ, project management, and so on and so forth. So now the question is, as we uh, go further, the market is going to be more aggressive, that the costs have to come down, the timelines will be more strict, and other technological drivers. So we have to be more efficient, we have to be more dependent on the technology, and how do we leverage those technologies to do better estimation, detail engineering, project execution, operation and maintenance, and other activities. So essentially what we are talking about is that we go more digital in terms of engineering, project management. We fall back more on AI and ML pieces in terms of gaining the intelligence, in terms of business analytics, so that whatever we plan, we are able to more precisely do the detail engineering and the execution. The future market is going to be something bigger projects, more pressure on cost and timelines, and technologically more ambitious. And so what we are going to cover in coming set of slides would drive towards uh, gaining those, creating the integrated workflow, number one. Number two is automation and integrating, all the best tools in terms of right from pre-bid to execution and maintenance. So there are two major parts of the solar EPC projects. This could be pre-bid engineering, where we do the yield estimation accuracy, condition modeling, BIM and GIS integration, surface analysis, module layouts, and shadow analysis. Then, of course, the next part is BOQ, the accuracy of the BOQ, the detail engineering, and the execution. So now I'll request my colleague Upendra to take on from here and take you through the capabilities of the solution. Essentially, we are talking about Autodesk bundles, which comes with more than 25 to 30 softwares, will help you do all these activities in complete one bundle, and also the third-party integration possibilities. So Upendra, can you hear me, please?
Yes. Thank you, Vyomkesh. And yes, thank you for giving us a complete brief about what exactly is pre-bid and post-bid, and also about the market segment of solar EPC projects. So yes, when it comes to like government initiatives nowadays, government is giving more emphasis on renewable source. Okay, so renewable source of energy. So therefore, therefore solar energy as it is renewable source, therefore, and we have the technology, right? Technology to take us to the next level where we should not be depend on the non-renewable resource like petroleum, coal, and all. Okay, so in that segment, uh, as we are moving forward and as more digitization is coming forth, okay, so therefore there is involvement of BIM integration. Okay, so all the tools which we have to use in future uh, technologies. So it should be like BIM, building information modeling, integration. Okay, so all the tools that should support that. Okay, now why that? It is like something what we had built. Okay, and it should have the information about the entire projects. We can extract it out at any level, extract it out during the design phase, during or during the implementation phase, during the execution phase, or even during the when we talk about the sustainable design. So everything comes under the BIM workflow. Okay. So yeah, can we have the next slide? Yes. So talking about the solar EPC projects, okay. So it's a um, it's a huge market now. Most of the industries are coming forward and taking initiatives in achieving the what the target government has decided. Okay. So therefore, Autodesk AEC solutions as well as the tools integrated to it. Okay. So now the more capabilities has been incorporated in Autodesk AEC solutions, and therefore, in from the inception stage of to the final delivery. Okay, so therefore, complete Autodesk collection can be utilized, and the capabilities has been developed. Okay, so therefore, for the complete industry from the surveying to the existing conditions of the modeling of the existing conditions. Okay, using initiating with the survey, then again building, designing and conceptually designing the existing conditions. Okay, taking it to the next level to the detailed design. So all these things can be performed using the Autodesk solutions. Okay, so therefore, uh, in today's session, I'll take you through the capabilities of Autodesk solution and how it will be quite beneficial and most widely used softwares and tools for Autodesk AEC for the solar projects. Okay, when it comes to surveying, okay, and taking the cloud data, extracting the cloud data. After extracting cloud data, the workflow goes like this. The initial conceptual design that we can perform. Now that conceptual design gives us the complete clarification about the existing site conditions. Okay, because there we can extract the features. Okay, trees, permanent structures, uh, the structures of higher elevations that can be extracted. Okay, so that can be extracted, and now that data is again like as it is interoperable all Autodesk AC collections. So therefore, the cloud data that we extract from the recap photo. Okay, so during the survey stage, during the surveying, because they're the stitching of the uh, drone shots and the photos that we take during the survey. Okay, that can be done using a recap photo, and then that data, uh, that tool gives us the cloud data that can be used in InfraWorks, and then uh, after doing the conceptual design, the detailed design, that data is again we can utilize in AutoCAD Civil 3D and also in Revit. So therefore, there are wide capabilities, and therefore we can use these softwares for existing condition modeling, also for plant layout and for civil engineering, about the complete slope and proper positioning of the solar panels. We can do structural engineering, like a structural design we can do, okay, of the steel structures where our panel can be fit. Okay, so that structure we can design. Now, the thing is, uh, when these technologies had not come, okay, so at that time, due to improper design, there is no proper wind analysis. So at that point of, there is no proper flood analysis. Okay, so at that point of time, like our site conditions and the complete environment are quite prone to uh, any such calamities. If occurs, then it will be, it gets destroyed very easily, and therefore, like the complete suitable and the most feasible conditions that can be analyzed using this complete tools which Autodesk AEC provides. Okay, so therefore we can also do the electrical and utility design, and there are tools for that as well. We will I will give you a complete overview of that in upcoming slides. We can do the simulations and analysis using InfraWorks, Civil 3D, and CFD. Okay, so that we can do. Also, the design we had made, the complete building, that building design we can, design in Revit, and we can do the um, like analysis part over there. We can automate that with the help of Dynamo Studio. So yes, it is totally a sustainable design principles. These all will follow. These all follows, and therefore helps us to gives us a complete, complete monitoring of our project, and therefore at any stage, if anything, if any changes required, we can switch to any tools, and we can do that. And as this is interoperable, so therefore we can use the versions. We can use the models which are used in like in all the tools which we had utilized for design as well as for execution stages. Okay, so yes, going forward, like as I said, conditioning of like existing model. If we have to, if we have to do the modeling of the existing conditions, like so there, initially what we have to do, we have to do the survey. Okay, so the land development part, as these projects are totally involved in land development, so therefore initially the survey is done. Okay, and the survey data that can be done using lidar scanning, okay, or by using the total station survey. So now if or by using the drone survey. Okay, so now that data is utilized, and the scan data that can be taken into the recap pro photo, as it is mentioning, and it has been mentioned already here. Okay, the tools which we can use. Okay, and that is a part of Autodesk AEC collection, that is Autodesk Recap Pro. There, like we have to import photos taken from the drone shots, and those data can are stitched after providing them with proper ground control points. Okay, so with that ground control points, after processing that image, we get the cloud data. Okay, and that cloud data is in the form of that can that can be utilized for designing purpose, for detailed designing, for conceptual designing, for realistic designing. So therefore the survey data is taken, and that survey point cloud data is again taken into InfraWorks. There, like and from then onwards, we can start analyzing our site locations, and whether that is feasible or not. Okay, so initial planning we can do. Okay, so after doing the initial planning, whether our site is feasible or not, we can if you can see over here, this is one. This is the data which is taken from extracted from recap photo. Okay, and with this data, now this is imported into InfraWorks. There, uh, the features we can extract. Okay, so these data, these features we can extract out of our InfraWorks. Okay, so and there are tools already in InfraWorks which helps us to extract the data which we had already imported. Okay, so like the center line of this road. Okay, if the also the edge of the pavement we can extract. So linear as well as lateral as well as any permanent structure that we can extract and we can design out of it. Okay, so therefore, and this is how we just proceed in our designing process, in our conceptual designing process. Okay, so now this is the imagery that the drone survey that is conducted. Now with this survey, as I had already mentioned. Okay, so the drone shots is taken, the data are collected in the form of photos, and they are stitched properly. Okay, and that data, they are like we can do the analysis of the shadow as well. That data are taken. Now these data are converted into the cloud formats. Okay, so therefore they are require the cloud credits in recap photo. Now that after processing that image, this kind of mesh can be created. Okay, so this mesh gives us uh, the entire features like the permanent structures, what is the elevation, what is our site conditions. So this is, and also doing the complete topography of our site location that we can extract out of it. We can model this. This is in the form of surface. Okay, so therefore, the elevation part we can extract the elevation of each any points from this cloud data. So therefore, initially, this survey part is conducted of the site location. Now, this after this after completing this survey part, okay, we can extract the we can the daylight conditions that we can check from our by integrating the ArcGIS connector. As we already know that ArcGIS is integrated with InfraWorks, and therefore which helps us to actually, what exactly is ArcGIS? So it is a GIS software, okay, like geographical information system software. So there, we can get the complete, it's a data at the center we have. In one sense, we can say that it is integrated with InfraWorks, and from there we can get the exact site locations in real time conditions. Okay, so therefore we can extract our models in the form of what, in the form of the roads. Okay, the component roads in along our site, also the utilities and ground networks connections and the permanent structures. All data we can extract from this ArcGIS connector, and this gives us a complete information about the helps us to about the solar radiation. Like in ArcGIS, we can also do the solar shadow analysis. We can also perform our we can perform we can design, we can completely check whether daytime what is the conditions of solar radiations, how much is the intensity, and all we can get out of this. So as this is totally a BIM process, and therefore now this helps us to evaluate our site conditions, and also the assessment study of our site location that we can do after using this ArcGIS connector. And that is a part which is integrated. Now ArcGIS integrated with InfraWorks, and that helps us in completely conceptualizing and getting the real time data into our design. And so therefore now moving to the surface analysis and contour grading, when we selected our sites, okay, and the surface we had already created. So therefore the next stage what we require is contour mapping. We have to do the surface analysis. Also we can do the feature theming, that what would be the elevation, and accordingly we can provide the contours with different sorts of elevation, like we can segregate that as well. Also, there is a grading optimization tool which is added to AutoCAD Civil 3D. Okay, so as grading optimization tool is added to AutoCAD Civil 3D, so therefore, like when we create our surface, we already had our surface. Okay, so it is very easy to do the surface analysis. Okay, the site which has been selected. So surface analysis can be done by making the solid models of our surface, and then analyzing that if there is any like change in any elevations or any uncertain elevations that can occur. Okay, that so that can be modified. So the surface can be analyzed, and then accordingly we can provide different themes, like different colors for different elevations, and uh, we can provide that theme to our surface. And then the biggest part comes is the grading, because any site which is selected, so it should have the optimized uh, earthwork calculations that gives us a complete overview about the estimate of our project. Okay, whether the estimated project is feasible or not. So therefore the grading optimization helps us a lot in when this tool has not been integrated. Earlier we used to do manual grading. Okay, so therefore site grading is a quite tedious task, because we have to provide slopes, and that too manually. So the process which takes hours to complete, that we can optimize within seconds, just providing the proper slopes to our uh, proper slopes to our design. So, and connecting them with different zones. So therefore it is quite helpful in plant layout, and surface analysis, contour designing, and using the grading optimization. So therefore these tools are used for that. uh, yes. Now when it comes to like the tools which where we plant layout, we have to do the plant layout design. So what would be the boundary conditions provided, and as per the boundary conditions provided, we have to give the zoning conditions to our plant. So therefore the we can select the rows, and where we can monitor uh, the length of the panel, okay, which has been provided. So therefore that monitoring can be done. And there are plugins already. There are custom plugins in Autodesk AEC collection, in Civil 3D, as well as in Revit. There we can analyze and we can monitor our design. Now, as I had already said, like cut and fill earthwork volumes. Okay, so this is the major part.
Restaurant. Now I've got a couple surfaces here. I've got one surface.
Yes,
If I
just
select
have a look at this
this is
video.
called survey. That represents the existing conditions. Let me select this other surface. If I hover over this, we can see this is called P-lot. This represents the proposed grading. In fact, if I come up and choose Object Viewer, we can orbit this, and you can see what that surface looks like. Let's close the Object Viewer. I'll press Escape to deselect the surface. I would like to create an earthwork exhibit for this site. Let's start by calculating the earthwork. I'll do that by going to the Analyze tab, and then I'll choose the Volumes dashboard. From here, I will create a new tin volume surface. A tin volume surface is a surface whose elevations are based on the difference between two other surfaces. For a name, we'll call this Earthwork Calcs. And then for the style, for right now, I'm going to choose triangles only. I'll click OK. For the base surface, I'll select the survey or the existing ground. And then the comparison surface, I will choose the proposed lot. I'll click OK. I'm not going to make adjustments to the cut and fill factors. We could adjust these if we were going to compensate for expansion or compaction of material. I'm going to leave those at 1 for right now, and let me click OK. There we go. My earthwork calculations are finished. If I drag this down to the right, we can see that I have a net of approximately 2,500 cubic yards of cut, so my site is long. We can also see that here in the graph. Let me click the check to close the panorama. So we've done our calculations, and now you can see this triangulated surface here that represents the volume. Normally we don't display a surface like this. One thing I can do is use this surface to colorize the areas of cut and fill. Let's do that. I'm going to start by creating a new surface style. I'll do that by going to the Settings tab. I'll open the Surface category, and then I'll right-click on Surface Styles, and I'll choose New. We'll go to the Information tab, and then for the name, I'm just going to use initials here. We'll call this JB Earthwork Display. Then I'll come down to the Display tab, and I'll say whenever I use this surface style, the only component that I want to see are the elevations. So I'll turn that one on, and I'll click OK. I will then assign that surface style to my tin volume surface. We'll do that by selecting it. I'll go to the Properties palette, and then I will select the style here from the list. I'll press Escape when finished. As you can see, the surface elevations are now colorized, although this colorization doesn't have much meaning. Let's change that. I'll do that by selecting the surface, and then I'll come up and choose Surface Properties. And here on the Analysis tab, I'd like to do an elevational analysis. Number of ranges, we'll set this to 2. And then I'll click the arrow to push that down to the details area. Using these two colors, I can highlight the areas of cut and fill. We'll take care of cut first. We can see the deepest cut is 5.59 feet. We'll take this up to a negative 0.5 feet. I will then click in the color field, and we'll choose a nice red color. Next, we'll take care of the areas of fill. For my minimum elevation, we'll set this to 0.5. We'll go all the way up to the maximum fill of 2.47 feet. We'll click in the color field, and I will set this to green, and I'll click OK. Basically what I'm saying here is if the existing surface elevation fluctuates up or down by 6 inches, it's essentially no change. Therefore, we are only colorizing cut greater than 6 inches or fill greater than 6 inches. Let me click OK. We can see that colorization. Now the surface is still selected. Let me right-click, and I'll push this to the back. I'll choose Display Order, and I'll choose Send to Back. Now, in addition to knowing my earthwork calculations, I can actually see where the cut and fill areas are located. Let's go one step further. I'd like to have an idea of how much cut and fill is going on in these shaded areas. We can do that by creating some labels. Once again, we'll come over to the Settings tab, and then I'll open up Label Styles here under the Surface category. We'll create a new Spot Elevation label style. I'll right-click on that group, and I'll choose New. For the name, once again, we'll go with initials. I'll just say JB Grid Ticks. We'll go to the General tab quickly. Let me click in the preview here, and I'll zoom in. We can see an example of the label there. Let's go to the Layout tab. Currently, we just have the one component, surface elevation. I'd like to set the anchor point to the middle center of the location being sampled. And then for the attachment, I'll choose the middle center of the text. This centers the text on the sample location. Next, we'll go to the Contents field, and I'll click the ellipsis button. We'll make a modification to the label itself. I'll do that by selecting this program code over here. And then we'll change the precision to the even foot. I will also change the sign. We'll open this up, and I'll say drop the sign. I don't need to see the negatives because I'll know it's a negative if it's in the red area because it's cut. Now that I've made those changes, I'll click the arrow to create the new code. I will then click OK and OK. Now that I've filed, I can do that by right-clicking. I'll choose Edit. And then for text height, let me click in this field. I'll click the drop-down, and I'll choose my no zeros expression. And I'll click OK. There we go. The zeros have disappeared. Let me back up, and I'll center this on screen. At this point, I've done my earthwork calculations for this site. I've also identified where the cut and fill is going to occur, and I've got a nice schematic that identifies the amounts of cut and fill. The best part is that all of this information maintains a dynamic relationship to the existing and proposed surfaces. This means that my earthwork exhibit is essentially maintenance-free. If I were to make changes to the existing or proposed surfaces, this exhibit will update automatically. Would you like to explore other AutoDesks, a proposed?
And therefore, in the previous video, as complete workflow has been shown about the earthwork cut and fill and the theme which we have to provide, okay, according to the cut and fill the requirements. And therefore there, like, we totally monitor our complete design, where we can provide with different styles to the different parameters whatever to the different entities. Okay, so therefore we have complete control over our design. And at any point of time, if a separate style, a separate layer, if we provide to the different entities which we are designing, so therefore it becomes quite easier for any time for a designer to maintain our drawing, uh, to check the rework, and also if there is any error that gets propagated, so that can be stopped at that point of time only. So therefore, coming to the next slide, where we, as we had already, checked about the earthwork calculations and all, how we can go for that when we selected our site. So we can also look across the approach road conditions. Okay, like the site which we had already decided. So there we must require an approach road. At the same point of time, we also have to do a drainage analysis. Okay, so now all these things we can do in Autodesk InfraWorks. Okay, so it is a part of Autodesk AC collection only. There, like approach road, we can easily model along our design sites, and that approach road is made as there are custom sub-assemblies for different types of roads are there. Okay, so already it is inbuilt in Civil 3D, and in InfraWorks also there are different sub-assemblies, so that after selecting that we can design different types of roads. Okay, 2-lane, 4-lane kind of roads we can easily design as per Indian standards, because as we all know, in as after incorporating India country kit, there are multiple sub-assemblies which are already uh, pre-installed in our design in the form of in tool palettes, where we can click and we can select that, and we can get the different types of sub-assemblies as per IRC norms, as per like 2 lanes, 4 lanes. We can also get different kinds of curves. We can also get side lanings and all sidewalks. We can also provide the daylight conditions to our design. Okay, such that when we visualize that in InfraWorks. Okay, so at that point of time it should totally look like we are designing that in the real conceptual model. Okay, so therefore it seems like totally realistic. So yes, talking about talking about the next slide, where uh, we talk about the utility and trenches. Okay, so yes, utility design it's a very important one of the tools which is which is a part of Autodesk Civil 3D, where there are pipe conditions are there. So accordingly, we can design different types of pipes. Okay, so as you can see over here, like we have the control over the what we prepare along the ridge line. Okay, we have to create our alignment, and with that alignment, we like that alignment can be used for for the road design and all, for selecting our complete zone. Okay, with the site where we had decided. there like we can monitor the profile of it. We can check what is the proper elevation, whether it is maintained or not. So all those things we can monitor. And there is alignment layout tools, and also alignment. There are different features. So after creating alignment, we can create profiles as we already have surface. Okay, so therefore it is a complete workflow which we have to follow in order to get the complete um, like different sections and different elevations. If we have to extract from our drawing, we can design that, and accordingly we can get the complete feasibility of our project. So therefore, utility of design we can do. Okay, there like we can also modeling we can do, and we can also extract the bill of quantities and all, because as with different utilities, standards are there. So therefore, we can easily extract the types of utilities, and the as per the condition, uh, requirement, the utility report we can generate out of our drawing. Now coming to the structural design, as we had already covered our contour and conceptual design and detailed design about our plant layout and all. Okay, so therefore, when it comes to like structural design, so there are optimization tools. Okay, in our AEC collection. So there we can easily design our steel structures. We can design our frames where we can set the solar panels and all. So therefore, the complete analysis like wind flow analysis we can do. We can do shadow analysis. We can also do the you know the heat analysis also we can do using the tools which we have like Otis CFD and Nastran. Okay, so now these are mechanical tools. So therefore these will help us to uh, design our frames. Okay, where be it feasible for that like temperatures or not. So therefore uh, such that the life cycle of that project, okay, that gets increased. So only because of that we have to optimize our design. Okay, so coming to the modeling and analysis and BOQ part of the setup which we had already created. So they're like the setting of the solar panels and columns and the angles. Okay, that we can check. Okay, and as per the shadow, after doing the shadow analysis, we can create this solar like setup. Okay, the entire setup of our panel. So the frame, we can do the frame and part settings. We can do our complete layout. We can generate us. We can totally generate the piling conditions as well. Okay, so therefore we can create these with the tools. Also, we can do this with the terrain meshing ability. Okay, and therefore after doing that, we have to do the electrical and utility. And for that, modeling and analysis we have to do. So for electrical and utilities, we just have AutoCAD electrical for that as well. Okay, where electrical, conditions, where electrical connections and types of utilities that can be, um, designed, and it can be put forth into our drawing, and accordingly we can decide the type of our the type and the placement of our panels, such that with different angles it can with a particular angle it can at different at different hours of a day, it can extract the most of the radiations, and that can be stored for and can be processed. Okay, so for utilizing the electrical energy. And therefore, Autodesk AEC collection helps us to do the complete electrical and utility design. So we can have complete control over that as well. Okay, so therefore, there are custom plugins for that. Okay, we can utilize that for our design optimization and all. So therefore, when it comes to like substation part, so we all know that there is civil part, okay, where we have to construct the complete layout of our design. We have to do building design of substation. Also, there is electrical part where we have to do the uh, electrical linings and all. We have to do the complete report of our electrical design, and that can be generated in the form of plans. Similarly, the civil part, the report can be generated. Coming to the MEP, where mechanical, electrical, and plumbing part, the complete design we can do, and these 2D designs can be stored in Autodesk docs, okay, and can be utilized at any stage of our designing process, because at the end we have to submit this to our client. Okay, so therefore these things are totally monitored, and the revisions can be monitored at any point of time. Therefore we have to utilize Autodesk docs, which is a central platform which can be access to all the, which can give um, a complete monitoring to our designs at any stage of time, be it the designing stage, during the any change, if there is any change required during that stage, or be it the later stage where we have to execute the entire project. So therefore complete documentation and its monitoring can be done, and keeping all the keeping all the designing team, the reviewing team, to the final authority, okay, keeping all in a single platform. So therefore at any stage of time it will becomes quite easier for us to get the approval of our design. So therefore our desk docs plays an important role in this section. Yeah, so yes, moving to our cable hangers and all. So therefore, this scheduling part we can do in our Navis work. Okay, so accordingly, the like this, as we can develop this with the help of Revit. Okay, the entire BOQ which is reflected. So this is the report that we can incorporate into our Navis work for proper scheduling as well. Okay, so we can extract the entire data. We can extract. So therefore, it will help us in providing the the proper bill of quantities, and by provide, we have complete control over each and every part, each and every design, or each and every structure which we have already created. Like if you can see over here, there are cable support cantilever hanger. Okay, so it is 2 tier and 600 so at any point of time, if there is any change is required, okay, so we can change it to the required uh, parameter which we have been subjected to do. So at that point of time, the reflection is directly into our bill of quantities according to the the according to the price and rates which we have been provided. So it is separate for each and every types, each and every panels, and like it is different for different sorts of um, frames and different types of different angles of steel structures. So therefore these like here is one example you have for this cable ladder support, and this we can develop in Revit. So coming to like overall model in Revit, like overall modeling we can do in Revit, the structure which we have to design along our side. So for that, as we had designed our plant, and we have to store the entire energy. So therefore, in plant we have to we can entirely model our structure, building structure in Revit. Okay, after designing it in Civil 3D and incorporating all the utilities, all the tools, all the electricals, all the MEP structures. So all those can be, analyzed in our in the Revit structure, and there we can easily also in Revit we can perform the shadow analysis at the same point of time. So it is one feature also, important feature in AutoCAD in Revit. So therefore, a complete overview about this uh, for different stages, okay, of development, where at planes level of development, how it looks like, okay, in Revit. So therefore, substation full view, if you can see, we have ground floor, we have basement, okay. So planes level, all we can control, okay. So ground floor at different stages, so different layers we can provide, and accordingly, with different levels, we can get also we can incorporate the complete design in the form of what we have already done in the electrical design, okay, that we can incorporate into our Revit design, and we can visualize that as well. Okay, so therefore, similarly, we have equipment, the equipment which are used like transformers and all, those also we can visualize uh, in in Revit, what we had designed already designed in other tools of Autodesk AEC collections. Similarly, like a gas insulation station, if you are seeing over here, conduits are already visible. Okay, so therefore, Revit, which is for architecture, okay, for MEP and for building design. So therefore, it can helps us to completely design and visualize our complete uh, complete project. So therefore, gas insulation station, if you can see, we can check the types of we can check the type of conduits which can be which we have to incorporate into our design with the help of the thickening of the wires which we have to provide. So with that, the gauge length of the wire, it decides the conduit length. Okay. So therefore, HVAC design also, next to this, we can do the HVAC design as well. Okay, so and these things can be directly presented to the final authority for their approval. Okay, similarly, if there is any clash detection, that we can easily do using the Navisworks tools. Okay, like lighting and firefighting portion also. Now, as we have complete control over each and every, as we have provided this with different themes. Okay, so therefore we have a complete control over each and every. We can, hide the other layers, and at the same point of time, we can, we can make it visible to the designer or to the approval team. So therefore, it becomes very much. Yeah, it becomes quite helpful for us, to completely visualize our design. So therefore, if you are seeing here, like advanced simulation and integration, these are the capabilities. Okay, so these are the capabilities of AEC tools, where like simulation and integration, what we can do the shadow analysis. Okay, we can do the PV system integration into our design. So after doing these simulations, we can get the after designing our project, we can get whether our project can sustain the extremities or not. Okay, whether our project is whether our design is optimized and giving us is giving us the proper result or not. So therefore, is giving what is the target, is it achieving or not. Okay, so at a particular point of time. So therefore, keeping everything, every how much kilowatt of electricity generation, whether our design can do or not. So overall, the entire study gives us a complete overview of that only. So therefore, we have like sun and sky setting we can easily do. Okay, to our panel, and we can analyze the shadow, okay, whatever following into our panels. Okay, so therefore at different stages of day, okay, different hours of day, we can easily check, we can easily monitor our shadows, and which helps us to, helps us to give us a complete idea about the positioning of the panels. So there is integration with Autodesk, integration with PV system and SketchUp and many more, such that the data can be, the file which we had already created, that can be visualized or can be utilized in other software tools. So this is all about the interoperability. Okay, so this facility, this ability has been given to Autodesk AEC collections. Yes, coming to the connected BIM workflow now, as I had already told you, like, if everything is in cloud, so it is very easy to monitor. So that's why I just give you a complete, I had already given you complete information about the BIM information modeling. Okay, that is building information modeling. So therefore, our building has the level of details to the extent how much details we can extract out of it. Okay, so therefore with designing these tools helps us to integrate the level of detailing, okay, into our project. So therefore that can be helpful for us at different stages of work progress, as the work progresses, okay, of the project. So therefore gives us complete monitoring, okay, at the same point of time. Like there is Dynamo or AutoCAD Civil 3D, okay, which can helps us to design our proper existing conditions, whether our positioning is right or not, because designing a simple designing a single object, okay, and making it useful for all it becomes quite easier in Dynamo. Okay, so just we have to do the scripting part. Okay, so this is all about scripting, where we have to do like this whole EPC structures that we can easily design for one, and we can implement it for all the in like this is the alignment design, and if electric poles we have to create, we can script for only one pole, and we can implement it for all the poles along the alignment. Okay, so therefore in many cases like electric poles, railings, okay, so also positioning of the solar panels, also we can do the scripting part. Okay, so therefore the rework for different for each and every, like if there are 10 numbers of electric poles, we have to do the scripting for 10 number earlier, like we have to design that in block. Okay, so now doing the designing in a single stage for a single part, and we can implement it for all the also like let me like value justification when we incorporate this AC collection. Okay, so when it comes to like timeline for a 750 megawatt solar project, so when we call for different quarters, okay, so if there is estimated timelines for Q5 till Q5, okay, at different stages, what is the operation, maintenance, construction, so doing the traditional way, okay, existing base timelines, and after utilizing our the Autodesk AEC products, okay, tools. So if something in different months like Q1 and Q2 takes, okay, like identification of land parcel and calculation, so initial finalization of our EPC project, if that is done, like initial finalization is done, so because that requires a survey also, okay, so it is quite time taking. Okay, so therefore it going through the normal using the normal tool, using the traditional tools, and that that will take us to the M6, okay, 6 months of time duration. So therefore that can be achieved in 3 months of time durations by using this BIM workflow. So therefore 50% of time saving we can do. Okay. Similarly, DPR preparation. Now, one thing I would like to put forth to you all, like DPR, detailed project report, it's a complicated thing to complete, right? It's a difficult thing to complete. Why? Because it requires a lot of reiteration, because we have to get approval for each and everything from the authority. Okay, so therefore, if everybody, like all, as I said, if we have like BIM integration and we are connected with Autodesk Docs, okay, at the same platform, if we are connected, so it becomes quite easier for us to get approval. So therefore, after implementing BIM workflow, we can save 15% of time there. Similarly, in basic and detailed engineering design, we can, save time to 55%. Similarly, in scheduling, planning, and procurement management, we can do 50%. And in construction stage, we can do 45% of our time. So therefore, the value addition is has been done to the project, and it justifies what. Now this report is not taken from anywhere, but this is in real conditions, like in real scenario, the companies are utilizing and they are benefiting out of the AEC products. Okay, so therefore it becomes quite useful for most of the organizations where they are using it and optimizing it for their projects. Okay, so coming to this is all about the capabilities. So one more thing, like we can also do design drainage analysis. We can do flood analysis. Okay, we can do various simulations using AutoCAD, Civil 3D, InfraWorks, Recap Pro, Revit. Okay, and Navisworks. Altogether, these tools will not only helps us to achieve the deadlines, meet the deadlines, but also uh, helps us to procure our projects in much more finer and in much more healthier way. Okay, so yes.
Thank you, Upendra. Thank you for very, very, high level but intense capability overview. So, gentlemen, we would like to open the floor for your queries. We are sorry because of the constraint of the time. We had to go a little fast, but this is possible. This is possible through one solution. We are not talking about multiple softwares and companies. This is Autodesk, bundle where all these capabilities are available. Some of you are already using these software, so we are trying to show you how it could be further, their utilization can be further extended, and which eventually integrates various workflows. It does an automation to an extent, and most of the activities what we discussed can be performed with little bit of support by companies like us. Thereby, we'll be supporting you in consulting, in training, and seeing that right kind of implementation. So we can have the questions. You could type it in the chat box, or we will unmute you all. You can just ask the questions and some specific requirements, whatever you have.
Yes, if you have any questions, you can open up. You can unmute yourself and you can ask your question, because yes, this is not very easy to get all entire overview until unless if you can't go through and if you can't implement these things into your project. Okay, so yes, you can come up with your queries.
So assuming they are not, multiple any queries as of now, but in the invitation you have my email ID. Please drop us a mail, and we will revert back to you with whatever possible support you need. So thank you, gentlemen. thank you very much for your time, and I hope the session was beneficial to you. Upendra, thank you very much, and the marketing team. So
Yeah,
we are-
thank you, Vyomkesh, and thank you, audience, and thank you for listening. At least you should have benefited out of it. Today's session we just gives you a complete overview about how we can utilize what this AC bundle for solar, EPC projects, and such that it comes, we can utilize it to the fullest. The only thing is that now there are targets so that we can achieve it after utilizing these tools. Thank you for you all to present in today's session. Okay, hope it will be quite beneficial to you all. I think we shall wind up if there is no questions.